Hi dear students, how many of you know how to calculate magnetic moment? Magnetic moment is one of the important concept under atomic structure for JEE and NEET. Magnetic moment is represented with mu, which is equal to root of n into n plus 2 Bm. Here Bm is nothing but Bohr magneton. What is Bm here? Bohr magneton. See here, magnetic moment is calculated by using the formula mu is equal to root of n into n plus 2. Here n is nothing but number of unpaired electrons. What is n here? Number of unpaired electrons. Unpaired electrons. See here, if we consider manganese ion, one of the manganese ion, Mna plus, it has magnetic moment as something like 4.9 Bm. What is the value of A? What is A here? And don't expect that in JEE and NEET they will ask direct questions. They will ask questions like this. Indirectly they will ask. And see here, Mna plus and its magnetic moment is 4.9 Bm. See here, simply I will tell you one trick here. If magnetic moment is 4.9, number of unpaired electrons, 4 electrons. If it is 5.9 Bm, then it is number of unpaired electrons, 5 electrons. If it is something like 3.8 or 3.9, then it is number of unpaired electrons is equal to 3 electrons. And if it is something like 2.8 or 2.9, then number of unpaired electrons is equal to 2 electrons. You follow this one, then you will feel more easy to calculate such type of questions. From this, we found that number of unpaired electrons is 4 electrons. See here, the magnetic moment is 4.9 in the sense number of unpaired electrons 4. When it will show 4 electrons, what is the atomic number of manganese? Manganese is 25. And what is the configuration? Argon 3d5 4s2. To show 4 unpaired electrons, it has to lose these 2 electrons and also one of the electron from this one. Then it will show 3d4. See here, now it has 4 unpaired electrons. When it has 4 unpaired electrons, by losing 4s2 electrons and one of the electron from 3d, means it lost 3 electrons. By losing 3 electrons, Mn becomes Mn plus 3. By losing 3 electrons, means it forms Mn plus 3. Now, Mn A plus is nothing but Mn plus 3, means A is equal to 3. Once again, briefly I will explain to you. The formula to calculate magnetic moment is mu is equal to root of n into n plus 2. Okay. Now here n is number of unpaired electrons. From the given magnetic moment value, we can tell number of unpaired electrons easily. There are 4 unpaired electrons. When it will show 4 unpaired electrons? By losing 3 electrons. By losing 3 electrons, it becomes plus 3, Mn plus 3. Therefore, A is nothing but 3. I think you got it. We will move to next one. Now we will find out the ratio of magnetic moment of ferric ion and dipositive cobalt ion. Ferric ion. See here, what is the electronic configuration of iron here? Argon 3d6 4s2, and cobalt, argon, 3d7, 4s2. See here, now we are going to find out the ratio of magnetic moment of ferric ion and dipositive cobalt. Ferric ion in the sense Fe plus 3, by losing 3 electrons it becomes Fe plus 3, means it has to lose 2 electrons from here, 1 from here, then it will show 3d5 configuration. 3d5 configuration in the sense, how many unpaired electrons are there? You have to write box method using Hund's rule. 1, 2, 3, 4, 5 unpaired electrons are there. And in case of dipositive cobalt ion, 2 means it has to lose the outermost 2 electrons, means valence electrons. And see here 3d7 electrons are there. We will check. 1, 2, 3, 4, 5, 6, 7. We have to follow Hund's rule. 7 electrons are there. How many unpaired electrons are there? There are 3 unpaired electrons. Here there are 5 unpaired electrons. Now, the magnetic moment of Fe plus 3 is equal to root of, what is the n value? 5 into 5 plus 2 by, we are finding ratio, that's why I am writing like this. Cobalt plus 2, how many unpaired electrons are there? There are 3 unpaired electrons are there. 3 plus 2, that is equal to 5 plus 2 7, 7 5s are 35 by 3 plus 2 5, 5 3s are 15. What is the ratio? The ratio of magnetic moment of ferric ion and dipositive cobalt ion is root of 35 by root of 15. And see here, they will ask indirectly. Don't expect direct calculations in competitive exams. See here, even though it is direct calculation, they are asking ratio. And once again, check it. Whenever you are finding number of unpaired electrons, you have to check the charge of that particular ion, and you have to follow Hund's rule by writing box method. Then only you will find out number of unpaired electrons. See here, if you are not following Hund's rule, you will not get number of unpaired electrons, and without number of unpaired electrons, you are not going to do anything with magnetic moment. We will move to next one. Here on board, if you observe, one calculation is there, very interesting one. Why it is interesting one, we will see. Which of the following has magnetic moment 3.873 bm? They gave different cations here. Chromium plus 3, cobalt plus 2, nickel plus 2, and manganese plus 2 is there. See here, how to find out which one of the following has 3.873 bm. In previous example, I already told you, if magnetic moment is something like 5.9, number of unpaired electrons 5. If it is something like 4.8, then number of unpaired electrons 4. From that, you can find out how many unpaired electrons are there if magnetic moment is 3.873. It's nothing but 3 electrons. Reason? I told you know the trick. You just follow that one. Means number of unpaired electrons 3. Now, here we are going to do, what we are going to do? Which one has 3 unpaired electrons? Okay. See here, chromium 24. What is the configuration? Argon 3d5, 4s1, and chromium and copper, it has exceptional special configurations. And see here, cobalt 27, argon 3d7, 4s2, and nickel 28, argon 3d8 4s2. Manganese 25, argon 3d5 4s2. See here, chromium plus 3 in the sense by losing 3 electrons. By losing 3 electrons it becomes plus 3. See here, by losing 3 electrons in the sense 1 from here, 2 from here, means it has 3. 3d 1, 2, 3. 3 unpaired electrons are there. And here cobalt plus 2 in the sense it will lose 2 electrons and 7 electrons. 1, 2, 3, 4, 5, 6, 7. Here 3 electrons. Here 3 electrons, 3 unpaired electrons. And next one, nickel plus 2. By losing these 2 electrons, it becomes nickel plus 2. Now we will check it. One, 2, 3, 4, 5, 6, 7, 8. How many unpaired electrons are there? 2 electrons are there. Now in last case, manganese plus 2. 25, and see here electronic configuration 3d5 4s2. By losing 2 electrons, it becomes Mn plus 2. By losing 2 electrons, it becomes Mn plus 2. See here, if you write the configuration 1, 2, 3, 4, 5. See here how many unpaired electrons are there? 5 unpaired electrons are there. A and B, chromium plus 3, cobalt plus 2, these two has 3 unpaired electrons. If there are 3 unpaired electrons, then we will get magnetic moment 3.873 Bohr magneton. Okay, here how many options are correct? 2 options are correct. And this is one of the most important question from JEE Advanced. In JEE Advanced exam, we will get multiple correct answer questions. In multiple correct answer questions, you have to check the options carefully, because we have more than one answer. That's why you have to find all the options, you have to calculate all the things, and the way how to calculate I already explained to you. Just by check the magnetic moment, from the magnetic moment you can find out number of unpaired electrons, and see here how many 2 options, they have 3 electrons. Okay, and we will move to next question, and before that please take the screenshot of this one. And here one more example is there on board, and here it is different case. See here, magnetic moment of vanadium with atomic number 23, chromium with atomic number 24, and manganese with atomic number 25 are X, Y and Z. Means they gave magnetic moment as X, Y and Z. They are asking what is the order of these X, Y and Z. See here I will give one hint to you. More the number of unpaired electrons, more will be the magnetic moment. In previous example we already discussed. Now this is a reverse one. There we discussed 5.9 in the sense 5 unpaired electrons, 4.8 in the sense 4 unpaired electrons, 3.8 in the sense 3 unpaired electrons. Now we are moving reverse. See here, now we will find out number of unpaired electrons in each case. See here, first we will take vanadium 23. Vanadium 23. What is the configuration here? Argon 3d3 4s2. And see here next one, chromium 24, argon 3d5 4s1. And next one, manganese atomic number 25, configuration argon 3d5 4s2. See here, Now we will write its configuration in box method. 1, 2, 3. 1, 2, 3. There are 3 unpaired electrons in 3D, and in case of 4s, it has 2 paired electrons, and in case of 3D, it has 3 unpaired electrons. 3 unpaired electrons are there. And in case of chromium, one, 2, 3, 4, 5 unpaired electrons in 3D orbital and 1 unpaired electron in 4s. Total 5 plus 1, 6 unpaired electrons are present in case of chromium. And here 3 unpaired electrons are there in vanadium. And next one, manganese, atomic number 25, configuration argon, 3d5, 4s2. And see here, 1, 2, 3, 4, 5 unpaired electrons in 3D and a pair of electrons in 4s. 5 unpaired electrons. 5 unpaired electrons in manganese, 6 unpaired electrons in chromium and 3 unpaired electrons in vanadium. More the number of unpaired electrons, more will be the magnetic moment. Then which one has more magnetic moment? What is this? Chromium. Chromium. Here they gave XYZ now. XYZ. Then it is X, it is Y, it is Z. Y has more, next Z and then X. Let us check the Y has more and then Z, and this is the correct order for magnetic moment. Hope you understood. Based on the number of unpaired electrons, the magnetic moment depends directly on number of unpaired electrons. More the unpaired electrons, more will be the magnetic moment. Based on the number of unpaired electrons, without calculating magnetic moment, we can write the order. And see here, if you don't know that hint, you have to calculate the magnetic moment. No need to calculate, just check the order of number of unpaired electrons. Based on that, you can write. And please follow all these things. All are important for your JEE and NEET exams. Don't neglect all these things. Very, very important areas for your exams. And especially I am selecting most important concepts for your IIT and NEET exams from different chapters. Now we are working on atomic structure, and please work on these things and share with your friends. Ask them to like it along with you, and don't forget to subscribe MrChemistry, our chemistry channel. Thank you.